All right, so if you have not watched the video, the first video from today's lesson, it's a video that was posted last Friday related to the Grassville math activity. So if you're not sure how to proceed with these problems, I would suggest going back and looking at the video first. It's kind of refresh your memory of what we did last Friday with the Grassville math activity. I'm going to be going through the problems here, and again, as I go through each problem, please stop the video, complete the problem, turn the video back on each time to see whether or not you're completing the steps correctly, if your understanding is correct, and then in terms of growth mindset, adjust whatever thinking you need to readjust so that as you work through the problems, your level of success increases. So going back to that Grassville math activity, when we pulled that 3 out to the right of the radical, what ended up happening was that the cubic root of 3 got replaced with an exponent of 1/3. So the cubic root, as well as the exponent's 1/3. If it's a fourth root, it's 1/4. If it's a square root, it's 1/2. So it's always a fraction that we're replacing the radical with. Using our rules in terms of multiplication of exponents, we're going to multiply through by the 1/3 exponent. So it'll be 27 to the 1/3, g to the 4 times 1/3, j to the 7 times 1/3, and r to the 6 times 1/3. So 27 to the 1/3, that doesn't change at this point. G to the 4/3, 4 times 1/3. J would be the 7/3, and r would be 6/3, which simplifies to 2. So we simplify the fractions if we can get a whole number answer or an integer answer, but if it's a fraction, we're just going to leave it the way it is. So 27 to the 1/3, g to the 4/3, j to the 7/3, and r to the 6/3, which actually is 2. Always have to check the number. It's one of the things that we had those last Friday. We had that one problem where you guys did all the steps and the rectangle would never turn green. And the question is, when we have the number, can it be simplified? Is 27 to 1/3 simplified to a whole number of some sort? So if you didn't simplify that to a whole number, please do that this time. So we're looking for our 3 numbers that multiply together to equal 27, and the answer is one of those. So that would be 3 times 3 times 3 is 27. So the answer of 27 to 1/3 is 3. So this is the final answer for number 1. So again, turn the video off and complete the problems on your own. Turn the video back on just as a way of checking what you're thinking. So like the video from last week in terms of Grassville math, we're going to pull that 5 to the right. And when we do that, the 5th root gets replaced with the exponent of 1/5. So the 5th root of this expression is the same as the expression raised to the 1/5 power. We're going to multiply through by a 5th. So we get 20 to the 1/5, p to the 7 times 1/5, and q to the 9 times 1/5. So 20 to the 1/5 stays where it's at right now, p to the 7/5, and q to the 9/5. So for the p and the q, the fractions are going to stay as fractions. We're not going to change them into decimal numbers. And then 20 to 1/5, again, this problem is not 20 divided by 5. It's can I find 5 numbers that are the same, that when I multiply them together I get 20. And if that does exist, then it means the answer is going to be one of those numbers. So if you had come up with this answer, think about it. Of course, you always have a calculator, because you always put the problem in the calculator to see if it comes out to be a whole number. I would prefer you think about the problem first and decide if it's going to simplify or not. So hopefully you decided it does not. This is the final answer. Problem 3 3 and 4, I've actually I've done something a little different. So the steps don't change. We're going to pull that 3 out to the right of, and which makes it 1 over w to negative 2 raised to the 1/3. Because the cubic root is an exponent of 1/3. So we're going to multiply the exponents 2 times 1/3, which gives me w to the negative 2/3. 2 times 1/3 is 2/3. So negative 2 times 1/3 is negative 2/3. And the directions where you need to simplify the problem so it has positive exponents. So I get this exponent positive, the w actually belongs to the numerator. So we're going to move the w up to the numerator, and the exponent becomes 2/3 now as a result. We're going to work on number 4. So you can complete number 4 using the steps from number 3. If you can back up the video a bit to watch it again. But the goal here again is having a positive exponent when we're finished. Alright, so in this problem here, if I pull the 4 out in front, it's going to be 1 over w cubed z to the negative 5, and the exponent is going to be 1/4. Because the 4th root gets replaced with exponent of 1/4, the cubic root gets 1/3, square root gets 1/2 as an exponent, 7th root is 1/7, and so on. We multiply through by the exponent, so we get 1 over w to the 3 times 1/4, and the z to the negative 5 times 1/4. So it becomes 1 over w to the 3/4 and z to the negative 5/4. Think about what the final answer should be, because again, we're all positive exponents. So again, we'll finish the problem off at this point, finish it off, and then turn the video back on. So hopefully you move the z up into the numerator, because I want to change the exponent from a negative to a positive. So the z would be in the numerator, z to the 5/4, and the w is still remaining in the denominator because the exponent is already positive. All right, problem number 5, cubic root of x equals 20. So we're going to be using the same techniques that we did last week, even before break, when solving rational equations. So the first step we talked about is to change these radical expressions into a rational expression so that we can use the techniques from prior to break. So go ahead and work on the problem, turn the video back on when you're ready to continue. So we're going to move this 3 out in front, and by doing that it becomes x to the 1/3 equals 20. Because the cubic root again is an exponent of 1/3. We've talked about that to be able to solve this problem, we're trying to make x equal 1. So that means we're going to be multiplying 1/3 by some number to make it 1. So think about it. I'm going to give it away quite yet, if you don't remember. So what number would I multiply the 1/3 by to get an answer of 1 for an exponent? So what we talked about is that we would use the reciprocal of 1/3. So we multiply by 3 or 3 over 1. So we multiply both sides by an exponent of 3, so I can turn the 1/3 times 3 into an exponent of 1. And it would be equal to 20 to the 3rd power. And 20 to the 3rd power would be 8,000. So think about the steps that we did for 5, and see if you can go ahead and finish off the problems for 6 and 7. One of the suggestions I made last week is that when you're solving rational expressions or you're solving radical expressions, you want to get everything else that's not part of the rational or radical removed from the side with the radical. Because what you want to do is you want to, like in problem 3, you want to change the radical into a rational expression and then change the exponent from the given one to 1. So in problem 6, same steps. We want to get that radical by itself. So anything else that's not part of that radical, we want to use our algebra skills to get rid of it. Same thing in number 7. So go ahead and solve the problem and turn the video on when you're ready to continue. Alright, so the fifth root of p squared plus 20 equals 66. So if I want the radical by itself, the first thing is hopefully you did was get rid of the 20. So in doing that, I get the fifth root of p squared equals 46. Now, this problem now looks like problem number 5. So at this point, whatever steps we did in number 5, we're going to do in problem 6. We'll get the radical by itself. So when we move that 5 over, basically, and when doing that, it's going to be p squared raised to the 1/5 exponent equals 46. And then this would be multiply the exponents together, so it will be 2 times 1/5, which is 2/5, equals 46. For the 2/5, we're going to multiply it by something and get it to a 1. So like the previous problem, remember the word, we're using reciprocals. So we're going to multiply by 5/2, because that would make the fraction equal 10/10. 2 times 5 in the numerator, 5 times 2 in the denominator. So the exponent becomes 5/2 on both sides. So the left side is going to be 10/10 for 1, and we're going to be doing 46 raised to the 5/2 power. So using a calculator, we're going to figure out what that is. If you think about the exponent 2, we're looking for 2 numbers that would multiply to 46, and there doesn't exist one. Now, if it was 49, for example, that would mean the number becomes 7 on that fraction of the denominator 2. But in this case here, we do not have a whole number. Keep in mind that when you're doing this problem, make sure you put the fraction 5/2 in parentheses when using your calculator. We talked about that last week before break, because your calculator is programmed to do the problem a certain way, and if you are leaving off a parenthesis for 5/2, you may find that you end up with a very different answer, because it'll do 46 to the 5th power, get that answer and divide it by 2, instead of doing 46 to the 5/2. So this one ends up being 14,351.410. All right, final problem. Again, same steps. We need that radical by itself, and then turn the radical exponent into a 1. So 4 to the square root of x minus 12 is 36. So first step would be to add 12 to both sides. And then we're going to divide by 4. So looking at the square root of 12. If I would turn this in as a 2, even though it's not written as 2, so it's 2 to the 1/2 equals 12. So if I multiply the 1/2 by its reciprocal, it's 2 over 1, or 2. We're going to have x the first on the left side, and 12 squared, which is 144 on the right side. So we will continue our work with radical equations. Hopefully you were very successful in these. If you weren't successful, and you really had to use the video, what I'd recommend doing is going back to the problems that you missed, and see, after doing them and seeing the video, can you go back and do the problems you missed without the use of the video now? How much do you remember the steps now that you have to go through to get that final answer?